Of what we're looking for, but we had to start planning it and building it even several years before this.
Right, exactly. It's great to see that we are here on this day for launch. Thank you so much for joining us, Administrator Nelson. Jim and Megan, back to you.
And we just heard that call out for stage 1 RP loading. Okay, we're coming up on another major fueling milestone now. Let's check back in with Daryl and Mick.
Right, Megan, stage 1 RP load complete, and so that completes the stage 2, rather.
Stage 2.
Complete. But we're continuing to load RP1 in the first stage boosters as well as LOX, which is the long pole in the tent. And as we look at this view from our Kennedy Flight Operations team and their Airbus H-135 helicopters, which are out there for security purposes, and they have a camera on board, thankfully for us, you can see the LOX clouds surrounding the rocket, which it's quite a humid day here in Florida today, Mick, so it really stands out dramatically.
Yeah, that cloud is caused from that boil off we talked about, Daryl, that once we start loading, that cold locks into the vehicle. We get boil off that occurs to allow the venting of the tanks so that we can get as much LOX into the tank as possible for today's mission. We want all of that propellant to be able to get Psyche on its way on that trajectory that Charmaine talked to you about.
Speaking of LOX, we are getting ready to start loading LOX into stage 2 of the rocket, the upper part. And you can see that
stage 2 LOX load has started.
And there's the call out. You can up to the second stage of the rocket.
Yeah, now this will be the last and final.
O microfone aqui.
We need to get on.
E aí, legal? Vocês, beleza? Deixa eu passar aqui o... voltar para cá. Bom, ótima segunda-feira, sexta-feira, bom final de semana, virando para a semana que vem. Um grande abraço para vocês. Fiquem todos com Deus, vamos continuar acompanhando. Daqui a pouco eu volto. Eu estou aqui fazendo ainda uma pesquisa aqui de alguns dados para trazer para vocês. E daqui a pouco a gente vem em definitivo aí no momento do lançamento aí do foguete, trazendo os dados para vocês. Faltando 17 minutos ainda para o lançamento. tem menos 17 minutos e contando, tudo praticamente perfeito, e daqui a pouquinho a gente volta. Bom, o lançamento está marcado para as 10 horas e 19 minutos, horário da Costa Leste, 11 horas e alguns minutos aqui para o Brasil. Vamos continuar ouvindo, daqui a pouquinho a gente volta, valeu?
Years to arrive at the Psyche asteroid. Why is that? Why so long?
Space is big, right? We live in a big solar system, and it takes a long time to travel between planets. 3 days to the moon, 6 months to a year to get to Mars or more. And so we are going on this looping trajectory from the Earth all the way out to Mars. We have to pass by Mars and get a little gravity boost from Mars. But then from there, we need to keep going out into the main asteroid belt, not all the way to Jupiter, but to about 3 times as far that the Earth is from the sun. And so it is just a long voyage, and it takes a long time to get there.
Yeah, and when the spacecraft gets there, it's going to observe the asteroid from different orbits, right?
Yes, so we will, you know, this is a model of Psyche. We don't know that the asteroid really looks like this. We don't know it's exactly this size. We don't know its mass to great accuracy, right? So we're going to very cautiously approach it and get captured in its gravity in a very high orbit that's something like 33 hours long, and really start to characterize it, get to know the place. Hey, look, we're here. Let's get to know the place, right? And then over time, we'll slowly lower that orbit, and eventually we'll be down in an orbit that takes only about 4 hours to go around the asteroid, and that's when we'll get our highest resolution data and all that chemistry data that we're talking about, and we'll be mapping the magnetic field and the gravity field the whole time. So yeah, that's why it's going to take us a couple of years, 26 months, to do that primary mission.
Yeah, a long journey for a lot of science.
Yeah.
Now let's get to another update from Raquel, who's live with JPL in California.
Thanks, Megan. I am in the Space Flight Operations Facility here at JPL, which operates the Deep Space Network. It consists of 3 complexes with large radio dishes that let us communicate with spacecraft that go beyond the moon. Now, these 3 complexes are strategically located in California, Spain, and Australia. They provide two-way communication and also help us track and navigate the spacecraft so we can keep them on course. And right now, the Deep Space Network is supporting over 40 missions. The Psyche spacecraft is expected to first communicate with the radio antennas in Canberra, Australia. Then data will come here to JPL. The operations team will use it to track Psyche, monitor its health, and send commands as it travels to the metal-rich asteroid. Megan, back to you.
Now, riding along with Psyche is NASA's first demonstration of deep space laser communications. Let's bring back NASA's Jasmine Hopkins to learn more.
Thank you, Megan. Yes, joining me now is Jason Mitchell and Trudy Cordes to talk to us more about the deep space optical communications, also known as DSOC. So, Jason, how exactly do these laser communications work?
Well, Jasmine, so just like on Earth, where space users are voracious for data, and so most of that data on Earth is routed through fiber optic cables with lasers, as everybody knows. We do the same thing for space users in this concept for things like DSOC, except can't tether a spacecraft to a fiber, so you have to do a free space link. And with that, there's at least 3 challenges. There's pointing becomes a challenge. You have to point very precisely. Plus, the Earth distorts optical light, right? And so you think about a hot road or the horizon of a hot road on a hot day, right? Like today, and you see that shimmer. And then 3, the signal is so faint, you literally have to count photons. So we have to have these super cooled nanowire detectors that are cooled to just about 1 degree Celsius above absolute zero. But you put that together and we get a capability to deliver data 10 to 100 times faster.
Right, so what we're doing is pretty complex. And Trudy, your directorate focuses on future technology. So how can we use DSOC in the future?
Right, Jasmine. So as Jason said, 10 to 100 times more data we're getting back. So it's very enhancing. For our friends in science, more data means more discoveries. And then certainly with all the work the agency is doing around Moon to Mars objectives, DSOC now gets into the to Mars part of that. So humans to Mars, a very realistic type of system we could use for reliable infrastructure such as advanced communication systems is absolutely enabling and going to make humans to Mars and exploration a possibility.
Exactly. I'm glad you mentioned to Mars. Jason, you are understanding DSOC on a deep level, and actually there will be something called O2O on Orion for Artemis 2. So how are they working in tandem?
So thank you. So the Optical to Orion will be another optical demonstration on that vehicle, and it will. So they're different missions, so they're different implementations, but they do share a lot of common hardware, and they will use the same high-efficiency photon algorithms, right? Remember that photon starved channel, got to count those photons. And that's how we'll accomplish that in injection or infusion into human spaceflight.
Right.
And Jasmine, just to add on, so Jason and I had the unique opportunity to go over and see O2O installed on the Artemis II service module yesterday. It looks absolutely beautiful. We're excited about that. We're very grateful to our friends in Exploration for, flying that for us to get this to an operational capability. And Jason knows what we like to say in space tech all the time. What do we say, Jason?
Technology drives exploration.
Bingo, exactly what Jason said.
Awesome. Great things to look forward to in the future. Jason, Trudy, thank you so much. Megan, back to you.
As you heard, laser communications will play a big role in our next mission to the moon. Let's see what else is already happening for Artemis 2.
It's a short package,
You would have thought it was launch day here at Kennedy Space Center just a few weeks ago. The Artemis 2 crew suited up in the historic Neil Armstrong Operations and Checkout Building. A test to practice a bit of what would happen before they lift off for the moon. Once their suits were on, they were off inside their brand new, fully electric crew transportation vehicles for the 9-mile drive to Launch Pad 39B. Kennedy employees waving to the crew as they drove by. At the pad, Commander Reed Weissman, pilot Victor Glover, and mission specialists Christina Cook and Jeremy Hansen took elevators to the top of the mobile launcher.
When we walked out that crew access arm, I just had images of all those Apollo launches and shuttle launches that I saw as a kid, and it was unreal. I actually had to stop and just stand a moment in the crew access arm to really let it all sink in.
The day's successful test ended in the White Room, their final stop before boarding the Orion capsule to the moon. That's your Artemis Moon Minute. If you're just joining us, welcome to live coverage of Psyche. Liftoff aboard a SpaceX Falcon Heavy rocket is now just 10 minutes, 13 seconds away. Atop in the payload fairing is the Psyche spacecraft, which weighs just about 6,000 pounds when fueled. That's about as heavy as a large SUV. It's made up of a body and 2 solar arrays in a cross formation, and when those solar arrays are extended, the spacecraft measures about 81 feet, or the size of a tennis court. It will be propelled by solar electric propulsion and will travel about 2.2 billion miles to study the metal-rich asteroid also named Psyche. Now, Jim, you are one of the scientists behind this mission, a mission more than 10 years in the making. How are you feeling now with 9 minutes and 30 seconds to go before launch?
Oh, my goodness. I have butterflies the size of pterodactyls in my stomach right now. But really, I'm thinking about the team.
Yeah.
Right? I'm thinking about the hundreds, the thousands of people around the world, across the country, around the world, who have worked so hard to get to this point. Launch is the focus of a big team effort, and I know there's lots of folks out there on pins and needles right now.
Absolutely.
But also, I think we're also just super confident in the team at SpaceX, the team here at Kennedy, to get us up there into space and give us a great ride.
Yeah, and this mission could benefit planetary science for generations. So impactful.
Absolutely. I mean, we won't get to Psyche till early 2029, right? So you think about a lot of the kids watching at home today or in school today, they're going to be the researchers who start working with the data in the 2030s and beyond. And we're going to have that data set coming in for a couple of years and hopefully learn a lot about planetary cores, the Earth's core, how planets form, and all kinds of cool things like that.
Jim, I really can't wait to see what you all uncover. Yes. You can't wait either.
I can't wait either.
Pterodactyls in your stomach. That must feel awful. And now taking us through the rest of the launch countdown are Daryl and Mick.
Thank you, Jim and Megan. Appreciate all the knowledge we are getting about the Psyche
Center
mission
core
today.
RP1 load is complete.
And there we just heard a call out that the RP1 load is complete, and that's great news. We're continuing to watch as this vehicle is tanked with propellants, 2.8 million pounds of propellants, both liquid oxygen and refined kerosene, called RP1. We've got a number of things that we are going to be looking at as we count down in the final minutes, Mick, and one of them is chilling the booster engines, transitioning the power to internal from shore power on the ground to internal to the rocket and the spacecraft.
Yeah, absolutely. As we're tanking the launch vehicle, there's also things going on with the spacecraft, and the spacecraft team is working all of their ops, transitioning to internal power, getting ready for this morning's launch. And we just heard that they confirmed communication with the spacecraft after a short transition, and we'll verify that they're on internal power here shortly. But things continue to look nominal for this morning's launch attempt.
Muito bem, estamos de volta agora em definitivo.
As we go along, updates about when each booster
Bom, carregamento perfeito do combustível. Agora já a contagem começa em T-7, faltando 7 minutinhos para o lançamento. Deixa eu baixar um bocado aqui o áudio da NASA. Muito bem, é o líquido, oxigênio líquido e tal, deixa eu ver aqui. Bom, os engenheiros continuam o seu trabalho, tudo nominal. Faltando aí T-6 minutos e contando. Deixar meu grande abraço ao clube, lá, o grupo Cafezinho, lá do nosso amigo Ozzy Pena. Deixar o nosso abraço lá a todo o grupo. Deixar também um abraço aí pro pessoal, um bom dia também, um bom final de semana pro pessoal no Facebook, lá dos grupos de astronomia. Lembrando que esse aí é o Falcon Heavy, com os seus 12 boosters laterais. Tem -5 contando. Bom, esse lançamento está enviando uma espaçonave chamada Psyche e a um asteroide do mesmo nome para aprender como a Terra e outros planetas rochosos se formaram. O asteroide pode fazer parte do interior de um planeta sismal ou um bloco de construção de um planeta rochoso. Haverá 2 transmissões de lançamento. Já começou, né, a cobertura inicial, e daqui a pouco, a partir das 9h30 horário da costa leste, já começou também a transmissão para o lançamento. Essa é a primeira missão para estudar um asteroide rico em metais, que é o Psyche, e visar ajudar os cientistas a aprender mais sobre a formação dos corpos rochosos no sistema solar. Com a data marcada para hoje, 13 de outubro, faltando aí 4 minutos, tem -4 minutos para o lançamento, diretamente do Centro Espacial Kennedy da NASA, no pod 39A, no famoso 39A, e essa sonda viajará a 3,5 bilhões de milhas do seu ponto até o asteroide. E também passará também nos confins do principal cinturão de asteroides entre Marte e Júpiter. Então, segundo Golfo Launch, quer dizer, já está pronto para o lançamento, aprovado o lançamento, então contagem ainda em T-3 minutos. Travamento do carregamento completo. E o time continua e agradece a todos pela colaboração.
These 2 side boosters, they'll be coming back today, so if you're here locally, you're going to get quite a show. Boosters 1064 and 1065, which have flown 3 previous missions to DoD.
Bom, aqui estão 6 coisas que você deve saber sobre a missão. A primeira é aprender sobre os asteroides Psyche, que poderia nos dizer mais sobre as origens do nosso sistema solar, com base nos dados obtidos por radares e telescópios ópticos baseados na Terra, e também os cientistas levantam a hipótese de que o asteroide Psyche poderia fazer parte do interior rico em metais de um planete sismal. Um bloco de construção de um planeta rochoso que nunca se formou. Então, Psyche pode ter colidido com outros corpos grandes durante a sua formação inicial e perdido a sua rocha, a sua concha externa, né, de rocha externa. Os humanos não conseguem abrir caminho até o núcleo metálico da Terra, no caso. Por isso, visitar Psyche, melhor dizendo, poderia fornecer uma janela única para a história de colisões violentas e acumulação da matéria que criou os planetas como o nosso, por exemplo. Os cientistas levantam a hipótese de que o asteroide Psyche poderia ser parte de um bloco de construção dos planetas rochosos do nosso sistema solar. Estudá-lo de perto pode nos ajudar a entender como os planetas rochosos se formaram. Então, junte-se a nós nessa jornada ao primeiro asteroide rico em metais que a humanidade já visitou. Tem menos 1 minuto, contando 1 minuto e 30 agora.
Gas launch closeout.
Bom, daqui a pouco a gente retoma aqui os quatro restantes aqui, os 5 restantes itens aqui para a gente fazer a leitura aqui para vocês. Vamos aguardar aqui o lançamento. Tem menos 57 segundos para o lançamento. Vou para o lançamento. Todos os sistemas operando, tudo nominal. 30 segundos. Retirar a contagem.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, engine ignition.
Ignição, lançamento.
Liftoff of Falcon Heavy and Psyche on a mission to a
Ok, lá vai o Falcon Heavy com o Psyche, a sonda Psyche.
Vehicles pitching downrange. M1D chamber pressure is nominal.
Pressão nominal.
Power and telemetry nominal.
We're here to all the power telemetry nominal. We're also looking at the data for all 27 engines.
Falcon is supersonic.
All chamber pressures look good, and Falcon is supersonic.
Throttling down in preparation for Max Q.
Max Q se aproximando, que é o máximo ponto de resistência.
Max Q.
The side boosters will be at full power, and the center core will be at a reduced power to go through Max Q to reduce the pressures on the structure of the launch vehicle.
O Max Q, galera, é justamente o ponto máximo de resistência da estrutura do foguete. É o ponto máximo de resistência dele. Então passa nominalmente. Daqui a pouco vamos ver os 2 boosters laterais sendo desacoplados. Que com certeza vai representar um espetáculo fora de série aí no que tange ao seu pouso, né?
Those side boosters. The center core booster will continue on.
Então, já vamos ver daqui a pouco o corte dos boosters laterais. E o seu, olha lá, liberação.
Great shot there of the side boosters coming off the rocket.
MVAC engine chill has started.
Separação perfeita dos boosters laterais. O estágio principal continua sua missão.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape.
Bom, os dois boosters pousarão no LZ1 e LZ2.
After that cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside.
Back shutdown.
That was a shutdown.
Aí vamos ver a liberação do ferry.
Stage separation confirmed.
Estágio de separação confirmada. Lançamento do primeiro estágio. Perfeito, nominal.
Center core MPF is safe.
Calling out the communication stations. What a beautiful shot there while we had it.
Aí perda do sinal. Agora já vemos aí a telemetria diretamente do centro de controle da SpaceX. Aí vemos a liberação do ferry.
To the atmosphere, you can see the fairing falling away back to Earth. SpaceX has their recovery vessel.
Vehicle is on a nominal trajectory.
Their recovery vessel Bob is out in the waters right now, looking to recover both of them. Getting a good burn now from the second stage. This lasts about 4 minutes.
Aí vemos essa belíssima imagem do planeta Terra aos olhos da câmera do primeiro estágio, do segundo estágio, do lançamento, né, do propulsão do Psyche.
Clouds overhead on the left. Also tracking
all the data so far, telemetry is looking nominal. I see the telemetry chilling down the engines for the booster entry burn and the side boosters starting up in the telemetry. Everything's looking nominal. Vehicle second stage is performing very well. And side boosters are coming back. And there we just heard booster entry burn startup is happening. Seeing the entry burn getting ready to go on the side boosters.
Boosters entry burn shutdown.
And there we saw the booster entry burn on one and shut down. And
Então já vemos aí então os boosters laterais se aproximando, já entrando já na atmosfera, a nossa atmosfera. Já vemos aí a descida já de um dos boosters. E daqui a pouco vamos ver a queima de combustível para a redução de velocidade e o pouso no LZ-1 e o LZ-2.
You and I here at Hangar AE, just a couple of miles away from this landing zone, we certainly hear it and feel it.
Yep, and I see now that the side boosters are supersonic, transitioning to transonic.
That's a shot of the booster through a thin layer of clouds.
We hear the call out for transonic. Landing burn started.
Here it comes.
Ok, já vemos o primeiro pousando. Ok, primeiro, agora vem o segundo, e o segundo fazendo seu pouso também perfeito. Ok. Bom, os dois boosters já chegaram perfeitamente, fizeram seu pouso perfeitamente. Lembrando que esses boosters serão reutilizados, né? Ok. Bom, o segundo estágio já fez o mico, já cortou o seu... E agora vai entrar em órbita para depois fazer a transferência de órbita. Ainda vai ter outras queimas para que faça a transferência de órbita e aí sim possa seguir viagem em direção ao asteroide Psyche. Bom, galera, é o seguinte, deixa eu aproveitar a oportunidade. Eu vou continuar lendo depois os pontos sobre o que eu estava falando, sobre a missão. Algumas pessoas às vezes veem na transmissão da NASA alguns momentos em que fica quadriculada a imagem. Essa situação de ficar quadriculado é perda de sinal, justamente do enlace do centro de controle da NASA, ou no caso da SpaceX, ou de qualquer outra agência que esteja, no caso, operando. E depois, esse por sua vez, também... Deixa eu passar para cá. Deixa eu só abaixar aqui um pouquinho no outro, que eu estou ouvindo o mesmo retorno, daqui a pouco eu abro aqui de novo. Então, às vezes, dá aquela perda de sinal, e com isso fica quadriculado. E o pessoal às vezes fala, isso é CGI, é isso e aquilo. Bom, cada um pensa de uma forma. Eu só acho que isso, de certa forma, está totalmente equivocado, porque não é isso que acontece. Não existe CGI. Ainda mais num ambiente como esse, totalmente hostil, que é o espaço sideral, né? Inóspito e totalmente hostil. Então, não tem condições de fazer qualquer tipo de coisa nesse sentido. O que há justamente é a perda de sinal, de comunicação, de enlace do centro de operações com a espaçonave que está lá fazendo sua missão. Então, nada mais do que isso, tá bom, galera? Tira da cabeça de vocês de que isso é CGI, de que isso é mentira, porque isso, que aquilo, porque não existe. Ninguém iria gastar bilhões de dólares em missões como essa, num investimento que fosse mentira, não é verdade? Então é isso aí, é só a gente botar um pouquinho a cabeça no lugar, pensar direitinho, raciocinar e que a gente chega à conclusão da coisa. Então, a missão está apenas começando e o estágio no qual contém a sonda já está em órbita para outras queimas, para que faça a transição dessa órbita e aí sim possa seguir sua viagem. Okay? Então, você observa aqui na barra aqui embaixo, deixa eu mostrar aqui, deixa eu ver se eu vou fazer aqui. Tá, aqui ó, aqui embaixo aqui, dá para ver aqui ó, aqui embaixo aqui é a barra justamente de progresso da missão. Então agora está no Cycle 1, quer dizer, a primeira interrupção da queima de combustível, que é justamente o momento em que eles a sonda já entra em órbita, a sonda, eu digo, entra em órbita do planeta, e aí depois fará a transferência, novas queimas para a transferência de órbita, e aí sim seguir sua viagem. Bom, vamos fazer o seguinte, deixa eu continuar fazendo a leitura aqui. Então paramos no item 2, né? Bom, o asteroide também pode sugerir uma história diferente sobre os objetos do sistema solar que se formaram. Embora as rochas de Marte, Vênus e Terra estejam repletas de dióxido de ferro, a superfície de Psyche não parece apresentar muitos destes compostos químicos. Então isso sugere que a história de Psyche difere das histórias padrões, no caso padrão da formação planetária. Então, se o asteroide provar ser restos do material de um núcleo de um bloco de construção planetária, os cientistas aprenderão como a sua história se assemelha e diverge dos planetas rochosos. Então, se os cientistas descobrirem que Psyche não é um núcleo exposto, poderá revelar-se um tipo de objeto primordial do nosso sistema solar nunca antes visto. Bom, no terceiro, como eu disse, são 6. Então, no terceiro item importante que você precisa saber é que 3 instrumentos científicos e uma investigação científica da gravidade ajudarão a resolver essas histórias de origem do sistema solar e muito mais. Então, será usado um magnetômetro da espaçonave que procurará evidências de um antigo campo magnético no asteroide Psyche. Um campo magnético residual seria uma forte evidência de que o asteroide se formou a partir do núcleo de um corpo planetário. Bom, o espectrômetro de raios gama e nêutrons do orbitador ajudará os cientistas a determinar os elementos químicos que compõem o asteroide e entender melhor como ele se formou. Bom, o gerador de imagens multiespectral da espaçonave fornecerá informações sobre a composição mineral de Psyche, bem como também a sua topografia. Lembre-se da missão do Osiris-Rex? É bem semelhante. Bom, a equipe científica da missão aproveitará o sistema de telecomunicações para conduzir a ciência da gravidade, ao analisar as ondas de rádio com as quais a nave se comunica, e também os outros cientistas podem também medir como o asteroide Psyche afeta a órbita da espaçonave. Essa informação irá ajudá-los a determinar a rotação, a massa e o campo gravitacional desse asteroide, e oferecendo informações adicionais sobre a composição, a estrutura do interior do asteroide, e é isso, ok? Bom, no quarto, a espaçonave utilizará um sistema de propulsão muito diferente pela primeira vez além da Lua, alimentado por propulsores de efeito Hall. O sistema de propulsão elétrica solar de Psyche aproveitará a energia dos grandes painéis solares para criar um campo elétrico e magnético. Estes, por sua vez, acelerarão e expelem átomos carregados, ou íons no caso, de uma velocidade tão alta que criam um certo impulso. O gás ionizado emitirá um brilho azul semelhante ao da ficção científica enquanto segue atrás de Psyche no espaço. Quem lembra aí das séries aí, Jornada nas Estrelas, Star Wars e outras coisas assim, vê que é bem a tonalidade mesmo dos motores de suas naves. Quer dizer, a ficção se tornando realidade. É isso aí. Então, cada um dos 4 propulsores de Psyche, que operarão um de cada vez, no caso, exercem a mesma quantidade de força que você sentiria segurando 3/4 na palma da mão. Não entendi porque certas traduções são complicadas aqui. Então, no vazio, sem atrito no espaço, a espaçonave acelerar lenta e continuamente. Bom, o sistema de propulsão baseia-se em tecnologias semelhantes usadas pela missão Dawn da NASA, mas Psyche será a primeira missão da agência a usar propulsores de efeito Hall no espaço profundo. Bom, a quinta é que Psyche é uma colaboração. Claro, não poderia ser diferente, né? Uma missão tão complexa como essa, que exige realmente um investimento muito alto, não poderia ser somente da NASA. Então, tem uma colaboração. Então, a missão baseia-se em recursos do canal da NASA, universidades, indústrias. A investigadora principal é a Lyndon Elkins Stanton, que trabalha na Arizona State University, e ao permitir a colaboração com estudantes em todo o país, a parceria oferece oportunidades para treinar futuros líderes de instrumentos e missões em ciência e engenharia, e também para inspirar projetos estudantis envolvendo arte, empreendedorismo e também inovação. Mais de uma dúzia de outras universidades e instituições de investigação estão presentes na equipe dessa missão. O Laboratório de Propulsão a Jato da NASA, no sul da Califórnia, gerencia a missão para uma diretoria de missões científicas da agência em Washington. Gerenciando para a NASA e também pela Caltech em Pasadena, o JPL também é responsável pela engenharia de sistemas, integração e testes e operação da missão. O programa de serviços de lançamento da NASA no Centro Espacial Kennedy gerencia as operações de lançamento e adquiriu o foguete Space Falcon Grave para esta missão. Então, a equipe do Maxar Technologies em Palo Alto, na Califórnia, entregou o chassi de propulsão elétrica solar e o corpo principal da espaçonave e a maioria dos seus sistemas de hardware e também de engenharia. E por último, e não menos importante, o item 6 é que a missão Psyche quer que você também faça parte dessa jornada. A exploração espacial é para todos. E a página Envolva-se, e aqui eu coloco entre aspas, da missão destaca as atividades nos sites da NASA e também oportunidades, que incluindo um estágio anual para estudantes universitários que interpretarem a missão por meio de trabalhos artísticos e outros trabalhos também criativos, bem como também as aulas em sala de aula e projetos de artesanato e vídeo. Uma forma também de interação com a escola e toda a sociedade em si. Bom, as informações sobre como participar de uma experiência de lançamento virtual estão na NASA e o endereço é nasa.gov/specials, como SPSCIALS/virtual como VIRTUALGUEST. O link vai estar aqui na descrição. Bom, os sites da missão da nasa.gov, Psyche e psyche.aso.edu publicarão notícias oficiais sobre a jornada da espaçonave, e a NASA e a ASO também publicarão atualizações regulares nas redes sociais, no Facebook, Instagram e também no X. Bom, uma das formas também de você fazer a observação de todo o progresso dessa missão é através do Eyes on the Solar System da NASA. É uma ferramenta gratuita de visualização 3D baseada na web e rastreará a localização da espaçonave em tempo real. E aí você pode também visitar, e vou deixar o link aqui na descrição da nossa live, e você já pode clicar também nesse link, você já vai direto para fazer o monitoramento da viagem do Psyche, da sonda Psyche, para o asteroide Psyche. Bom, cerca de 2 meses após o lançamento, galera, isso aí vai levar mais ou menos uns 2 meses, enquanto a equipe realiza uma verificação inicial da nave espacial e também dos instrumentos científicos, a missão espera receber as suas primeiras imagens. Assim que a equipe confirmar que o gerador de imagens está funcionando conforme o esperado, uma página da web apresentará as imagens não processadas ou brutas que fluem diretamente da espaçonave. Bom, mais sobre a missão, no caso é uma demonstração de tecnologia chamada Deep Space Optical Communication, o DCOC, voará no Psyche para testar comunicações a laser de alta taxa de dados que poderiam ser usadas em futuras missões da NASA. O JPL gerencia o DCOC para o programa de missões de demonstração de tecnologia dentro da Diretoria de Missões de Tecnologia Espacial da NASA. Certo? Deixa eu ver se tem alguma coisa aqui. Sim. E o programa de comunicações espaciais e navegação dentro da Diretoria de Missões de Operações Espaciais também vão atuar plenamente nesse monitoramento. Bom, Psyche é a 14ª missão selecionada como parte do programa Discovery da NASA, gerenciado pelo Marshall Space Flight Center da agência em Huntsville, no Alabama. Bom, para saber mais sobre essa missão, acesse www.nasa.gov.br/Psyche. O link vai estar aqui na descrição, galera. Então, essas são as informações, são 6 tópicos importantes dessa missão, no qual você tem ciência, depois você pode voltar à live também e assistir para você obter. Se bem que é aquilo que eu estou falando. Todos os links dessa cobertura estará disponível. Ok, gente? Bom, daqui a pouquinho a gente volta, vamos tomar ali uma aguinha rapidinho, a gente dá uma respirada, daqui a pouquinho a gente volta. Obrigado a todos pelo like, obrigado, se puder, se não é inscrito no canal, por favor, se inscreva, deixe o seu joinha, compartilhe com os amigos, por favor, nos ajude na divulgação do nosso trabalho. Fazemos o nosso trabalho aqui com seriedade, com responsabilidade e compromisso a vocês, tá bom? Meu nome é Robson Rodrigues, sou repórter, editor e apresentador do canal Olhar Sideral, e você está assistindo a mais uma cobertura de lançamento da NASA / SpaceX aqui no canal Olhar Sideral, tá bom? Daqui a pouquinho a gente volta.
Relaxing cruise to the asteroid, and I just can't wait to see what we find when we get there. I'll be on this journey to a metal world every step of the way.
Thank you, Christina. Back to you, Megan.
Now we asked for questions and you sent them in. Jim,
yes.
Are you ready to answer?
I am ready. Bring them on.
I wasn't ready to say that, but now I'm ready. Okay, so let's play the first question.
I am Paola and I'm from Serrano Elementary School in Moreno Valley, California. And my question is, how much time is Psyche gonna spend studying Psyche 16?
It's a great question that Paola asks. And so first of all, it's going to take us almost 6 years to get there.
That's
right? So we have to fly by Mars and slowly coast out, power ourselves out with those electric thrusters. And then when we get to Psyche, we'll start up high in this 33-hour orbit, and we'll spend a little more than 2 years, 26 months, slowly getting closer to the surface and getting a higher and higher resolution, map this whole thing and get its chemistry and magnetic field and all that kind of stuff. So about 26 months.
Awesome. Great question, Paola. All right, let's take the second question now. How can an asteroid have enough mass and density to support a molten metallic core?
That is an outstanding question, and the answer we think is that this asteroid was part of something much bigger, right? And so it had more gravity, and with that gravity comes internal heat, pressure, internal heat, and it's got radioactive elements inside of it as it was forming, and so it's really hot on the inside and it can get molten. And we think that the part we're seeing now is just what's left over after maybe a big impact, a grazing impact, knocked off the mantle and crust. We're going to test that hypothesis with the Psyche mission.
Okay, let's squeeze in one more question. This is Andy Zhang on H. How long did it take to research and develop this mission and the Psyche spacecraft?
Well, it's the better part of 10 years.
Yeah.
You know, we saw earlier in the show that, it all started with some scribbles on a whiteboard and, folks thinking ideas about how can we learn about planetary cores, how can we figure out how planets form. We can't study the Earth's core. Hey, let's go visit a metallic asteroid that might be the remnants of a core. And so that idea from sort of 10-ish years ago became a proposal, a pitch to NASA in a competition that we won to mount a Discovery class mission. And the spacecraft started getting built. We got selected in 2017, and then probably about 2018 or 19, we started building and testing the spacecraft.
Mm-hmm.
Here we are in 23, and it's off the ground.
And you know what? I just realized I never said congratulations to you.
The whole team, it's really, like I said, everybody's just ecstatic right now.
Yeah. Okay, great questions, guys. Keep them coming using hashtag AskNASA. But right now, I need you all to take out your phones or get ready to take a screen grab if you're watching us on your phone. We're going to pull up another QR code for you, and this one will take you to NASA's Eyes on the Solar System page. This is really cool. You can track the Psyche asteroid's current location along with other asteroids and comets in our solar system. And once the Psyche spacecraft is communicating back with us on Earth, then you can also track its location too. Now, the Psyche spacecraft will gather new data that will be studied by researchers around the world, including the curator in charge of the U.S. National Meteorite Collection at the Smithsonian Museum of Natural History. Take a look.
When I was a little kid, I thought I wanted to be an astronomer. I took a geology class, and there was just something about having a rock in your hand, something you could hold and feel. I thought, you know, we have rocks from outer space. Maybe I'll study those. I study meteorites. I love meteorites. It's like an addiction for me because I love exploring the solar system through understanding these rocks and the places they come from. Life on Earth exists on two heat engines. One is the sun, but the other is the heat engine below our feet that drives the movement of the plates. It drove the differentiation of the planet. We've known for 2 centuries that our core was made of metal, but we haven't been able to explore it. We can't drill a hole that deep. We can't explore with any kind of submersible in the oceans. What we've been looking for years is a metallic asteroid, something that's very dense. Psyche is an asteroid 200 kilometers across, thought to be metal rich. Psyche is our way to explore our own planet. We have meteorites fall to Earth. Some of them are little tiny pieces. Some of them are the size of cars. But compared to Psyche, they're just tiny little specks of dust. When I first started as a graduate student, we had never visited an asteroid. Not any of them. Asteroids were points of light in the sky, and now they're real geologic places. They're places we can visit. More than the awe, more than the wonder, we have this responsibility to do this right. And that's why this part is so important. What we're doing right now, designing these
acquisition of signal,
that will
part of
determine
the
when we get the data. That graduate students 10 years, 20 years, 30 years from now will learn things about this asteroid that we can't even imagine today. It's the journey of a lifetime, and I didn't want to miss it.
Now, NASA has dubbed this fall Asteroid Autumn for all the fascinating things we have going on with asteroids around our solar system. For more on that, let's bring back NASA's Jasmine Hopkins.
Thank you, Megan. Yes, tis the season of asteroids. Here to talk to us more about Asteroid Autumn are Nikki Fox and Lori Glaze. Thank you for being here. We are so excited. So we are in Asteroid Autumn, but no missions are the same. Nikki, tell us what makes Psyche unique.
Well, first of all, Psyche just launched. So, I mean, it's right, awesome. So, but Psyche is going to a metal-rich asteroid, and there are only 9 that we know of in our solar system, but Psyche is huge compared to the other ones. It's the size of Massachusetts. So we're going to go and actually visit a metal world for the very first time. We don't know what we're going to find, and that's what's so exciting about NASA science. Every time we launch a mission, we do unique, cutting-edge science, and this one is going to be absolutely no different. We cannot wait to get that out there, that spacecraft out there with Psyche.
Exactly, that was the perfect way to characterize it. We keep doing unique first. So actually, Lori, you were just in Houston as well as the administrator for the unveiling of the OSIRIS-REx sample return. So what are we finding with that mission? What is next?
That is an amazing mission, and as you said, I was just in Houston 2 days ago on Wednesday. It was absolutely spectacular to be there and share with the entire world kind of our first look at what that sample is. But really, it's the very beginning of the analysis process. We've got so much incredible science to do, but what was so unique about that particular sample was we're finding water in the sample. We're finding carbon, an incredible amount of carbon, more than we've ever seen even in the meteorites that we
Jason, we're actually not at the end of asteroid autumn yet. The Lucy mission is about to have a close flyby, its first asteroid encounter since launching in 2021. What are we looking to find back?
So again, we're going to be going to an asteroid. It's a little one, so it's very, very different from Bennu, and it's different from Psyche, and we're just going to learn a lot, because it's going to be the very first time that we've actually visited this new world. It also gives us an opportunity to actually check out the instruments and make sure everything's ready for when Lucy actually gets into the Trojan belt and starts the flybys in there. And I have to just give a shout out to DART. It's also part of asteroid autumn, and we just celebrated that 1 year anniversary. It's on the nose, but Laurie is going to tell you why Lucy is so important.
Yeah, so the Lucy mission, as Nikki said, of course, is going to fly by a little asteroid in Lincoln. It's a main belt asteroid, but the real goal of Lucy is, at the end of this decade, is to explore several what we call Trojan asteroids. And they're Trojan because they kind of hide, right? You find the Trojan asteroids leading and trailing Jupiter in its orbit around the sun. Interesting fun fact, those asteroids, even though they're in Jupiter, the orbit that Jupiter's in around the sun is actually closer to Earth than Jupiter. But those asteroids are incredibly important for telling us about the early part of the solar system, where the giant planets were, and if they migrated or moved over time. Those asteroids were picked up and held in that gravity field over time. So the different asteroids we're going to visit will tell us about that history.
Exactly. A lot of great things going on with asteroids right now. Nikki, Lori, thanks so much for being here.
Go Psyche. Go Psyche.
Of course, go Psyche. Jim and Megan, back to you.
I love to see how excited they are. I also love that we do have this big screen there that's showing the trajectory again of that second stage with Psyche. Now we are 33 minutes since launch. Once this Psyche spacecraft is on its own, the spacecraft will use solar electric propulsion to move through space. Now that's a super efficient system being used for the first time beyond the moon. First, the Psyche solar arrays will convert sunlight into electricity. That electricity will power the spacecraft's 4-hall thrusters. Those thrusters will use electromagnetic fields to turn Psyche's propellant xenon into thrust, and that thrust will gently propel it into deep space while emitting that cool blue glow you just saw there on your screen. Now, Jim, when we're talking about gently, it is very gentle. Can you tell us about that?
It is very gentle. How gentle is it? It's so gentle. Hold out your hand.
Okay.
I have 3 quarters.
All right.
It has about the same amount of force as
Feels like nothing.
nothing.
Absolutely
It's like a
nothing.
bag of feathers.
Yeah.
Very, very gentle. So tiny but mighty. Because you exert that force just continuously. So instead of just like one big main engine burn, it's just a slow, gentle process with that beautiful blue glow.
Yeah.
And that accelerates us out to like 125,000 miles an hour in our journey out into the solar system.
And that's essentially because even though it's nothing, if there's no atmospheric drag to push it back, it just keeps accelerating. Interesting. Wow. Now, Maxar Technologies supplies Psyche's 4-hall thrusters. You can see them there. Engineers estimate that if this mission used traditional chemical thrusters, it would have burned through about 15 times as much propellant. Now, Psyche is carrying 3 scientists on board. Check out how they'll discover the asteroid's composition without landing on it.
Psyche is a unique object in the solar system.
To us, Psyche is this really unusual body giving off really unusual generating neutron signatures.
Technically, it's an M-class asteroid out between Mars and Jupiter.
One of the first things you want to know is what's it made of.
So the Psyche payload consists of 3 science instruments. One of them is what's called a gamma-ray neutron spectrometer. It's actually 2 separate pieces of hardware. One is the gamma-ray spectrometer and the other one is the neutron spectrometer. Both combined study the elemental composition of Psyche.
If you know the surface composition, what it's made of in terms of iron and nickel and silicon and oxygen, you can then start to say something about its history, how it formed and how it evolved.
By using gamma-ray spectroscopy, we can measure those elements remotely. We don't have to touch the surface. We don't have to dig into the surface.
For Psyche, we're building kind of what we call a cathode. It's a very high sensitivity instrument. It's very similar to the messenger instrument.
That technology we developed for the messenger spacecraft gave us a huge head start going to Psyche.
For our types of instruments, we don't get to fly them very often. So when we actually get selected for something, that's a big deal for us, where we can, take what we learned from the prior missions and implement it now and make it an even better instrument.
Our instrument is kind of like a camera without a telephoto lens.
In order to get our best measurements, we need to be relatively close altitude above the surface. That's what we call orbit D.
So we can form maps, global maps, of the elemental composition of Psyche just by flying around next to it.
You have galactic cosmic rays, that's a fancy word for very fast protons. They come in, they smack a planetary surface, they bust apart atoms in that surface, all the neutrons rattle around, and as they rattle around, they end up producing gamma rays, the neutrons that come out. And the gamma rays have energies, and they're like a fingerprint. So you get a fingerprint of different energies that says it's iron there, it's nickel there, it's silicon, and then how many of those gamma rays tells you how much of that element is there.
The first thing it takes to do a mission like this is a tremendous amount of institutional knowledge of all the different aspects, not just how do you build something, how do you aim something, how do you guide something, how do you get data from something, those technical aspects.
I feel like it's super important to have a team that you can trust because I guarantee that at some point something's going to go wrong. Probably many people in school for years of a project. So already it's happened that in my process of learning about the science, I've made small changes to the design to help optimize and help meet the science goals.
We're kind of the last instrument to get its measurements.
So there is a sense where you're on pins and needles until you get that data back, and then there's the big relief, the big excitement, and then you get to work and trying to say, what does all this mean?
So we'll deliver some excellent science in the end.
An active checkout of the instrument starts about 6 weeks after launch. Jasmine Hopkins got to speak with NASA's chief scientist, Kate Calvin.
Welcome, Kate. Thank you so much for joining us today. So Psyche is going to take us to a metal world for the first time. What scientific discoveries are we looking forward to?
Well, the Psyche asteroid could be the metallic interior of the remains of a small planet. So this will give us an opportunity to understand how planets like Earth formed. So 4.5 billion years ago, all the planets on our solar system formed from the same cloud of gas and dust. And Earth has a metallic interior, but we can't bore down deep enough to see it directly. And so by visiting Psyche, we have this window to understand the processes that led to creation of planets like ours.
And it's going to take us a while to get to Psyche, about 6 years. So what are the long-term benefits of a mission like Psyche?
Well, from a science perspective, scientists are hoping that it'll help us better understand planetary formation, including the formation of planets like ours. But Psyche also has a technology demonstration along with it. So it'll be a test of communication from space, the next generation way of communicating from space. So the deep space optical communication will be the first test of laser communication from out beyond the moon.
Right, so we actually have two firsts attached to the Psyche mission, Psyche and DSOC. And once we get to the asteroid, we're going to be taking all these pictures, and then those pictures will be open to the public. So why is it so important that NASA makes science accessible for everyone?
So NASA makes its science publicly available, and we're working across the agency to make it more accessible so that more people have access both to the information, but also understand what we do with that information. By opening science up to the world, we can do more and do it faster. So when we bring more people in and include them in our science, we can ask more questions. We can also answer questions more quickly. And this isn't just something we're doing with Psyche and with planetary science, but we're doing it across the Science Mission Directorate.
Exactly. We're actually doing it with Earth as well. We have the Earth Information Center now at headquarters. Can you tell us more about that?
Yeah, so Psyche is going to give us a little more information about metallic cores, and Earth has a metallic core. What the Earth Information Center tells us is a little bit more about what's happening on the surface of the planet and what we can see when we observe Earth from space. So we can learn about things like land use and land cover, we can learn about ice, we can learn about what's happening in the atmosphere and how that all impacts people here.
Exactly. Thank you so much for being here with us today, Kate.
Thank you for having me.
NASA and the Psyche mission team love engaging with the public and especially students. One program invited undergrads to share their creative works inspired by Psyche. So let's take a look at some of those submissions now.
Yeah. This is awesome.
That's so
I
cool.
love the way that we have artists and dancers and poets,
Yeah.
and writers and playwrights, and this is spectacular, beautiful views. There's
the colors
there's our
for this
mission
one is
color
great,
theme right
yeah.
there. Yeah.
And I love 16 Psyche is scripted right there,
Yeah,
really
with
pretty.
the spacecraft with its deployed solar panels.
Yeah.
Yeah, this is just beautiful stuff. Look
Oh,
at that.
that's cool. Look at the detail on Psyche there. Are your pictures going to look as good?
Just exactly. Yes, we certainly hope so. But boy, it's just beautiful fun to imagine.
Yeah, and it's so cool to see that both science and art, they can inspire one another.
Absolutely.
So,
Expecting
perfect.
lots of signal, hard to beach stock.
Now, if you want to see more artwork and other projects inspired by Psyche, take out your phone and scan another QR code we have for you on your screen. This one's going to take you to psyche.asu.edu/get-involved. Okay, and I do know that you have other space art. You're just so full of demos and props. I love it.
Space rocks, right? And I have a couple more space rocks. This is a slice of an iron meteorite. Let's see if I can hold it up to the camera there. It's a slice of an iron meteorite that's been polished. And you can see the beautiful grains, and there we go. You can see the grains in it.
So
and this is a mixture of metal and silicate rock.
Yeah.
And so this might be not polished, but might be what the surface of Psyche is like.
Oh,
but it's also,
interesting.
it's just beautiful. People put these on their mantle place and in their rock collections. You can collect these.
You said make
as
it
well.
jewelry too,
You can
right?
make jewelry
Yeah.
out of them, little earrings, a pendant, whatever.
That's cool.
I have another piece of space art. This is also a space rock. Let me
Okay.
hand this one to you. Tell me what you feel.
Oh, that's heavier than I expected.
Very
Wow,
heavy,
that took
right?
me
It's
aback.
a sphere that the artist has kind of carved out of a much bigger metal meteorite. And you can see all the little grains. And
Yeah.
it almost looks like a little mini Death Star,
It does.
right?
It does, actually.
And so, people collect these and trade different ones with their friends. And so there's lots of ways to use space rocks for art, too.
Yeah, thank you for sharing those. I really
Sure.
appreciate that.
Sure.
All right, it's now been about 44 minutes since launch. Our coverage is again going to take you through the deployment and first possible signal from the Psyche spacecraft. So let's check back in with Mission Control at NASA's JPL.
Thank you, Megan. Welcome back to JPL. We may be 2,500 miles away, but I can tell you the community feels connected. And here's a live look from Von Karman Auditorium. Just moments ago, it was packed with nearly 200 family and friends. This is where JPL hosts special events, and it's also where we display several spacecraft models. And there's a model of the Psyche spacecraft that I had a chance to see up close with payload manager Noah Warner. Take a look at why he says you can compare parts of the spacecraft to an electric car. Great to have you here, Noah. Tell us more about Psyche.
Yeah, I'd love to. So we're standing here with a quarter scale model of the Psyche spacecraft. And you can see even at a quarter scale, it's a very large spacecraft. The actual Psyche spacecraft is over 15 feet tall and 80 feet wide. And at launch, it weighs over 6,000 pounds fully fueled. Let me point out a few key features of the spacecraft. You see up top here is the high gain antenna under this silver blanket, and on front is one of our 3 low gain antennas. Also on the front of the spacecraft is the NASA technology demonstration instrument called Deep Space Optical Communications.
Psyche will use a special kind of propulsion system. What can you tell us about it?
That's right, we use solar electric propulsion. That means we gather energy from the sun through our 5-panel solar arrays. We convert that energy into electricity and use that electricity to drive our Hall effect thrusters, 2 of which you see right here. They're 4 to 5 times more efficient than a chemical rocket. You can think of a chemical rocket almost as like a gasoline-driven, high-performance sports car with lots of acceleration. Whereas our Psyche system is more like your highly efficient electric car that gets you everywhere you're going on the minimal amount of fuel. Hall effect thrusters use xenon as the propellant. They ionize that propellant and accelerate it out at tremendous speeds. They also generate this beautiful blue plume.
Wow, and right now it's packed up in the spacecraft. How do we get it to look like we see it right now?
That's right. At launch, these 5-panel arrays are stored flat on the side of the spacecraft. And a series of cables, springs, latches, and dampers will choreograph that deployment such that the first 3 panels in line here will deploy first, and then the side panels will come out one at a time after that. And then the spacecraft will start looking for the sun and get those arrays pointing directly at the sun to get full energy. At that point, the spacecraft starts a rotisserie move where it rotates about once an hour, establishes communication with the ground, and then the operations team can start to check out the spacecraft and get Psyche ready for its journey.
So what are you looking forward to on Psyche?
I think I'm looking forward to the science investigation and frankly, the fact that we're going to a world that we've never seen with our own human eyes. We don't really know what we're gonna see there, but I think we've got the exact right suite of science instruments to figure it out once we do get there.
Thank you, Noah.
Riding along on Psyche today is NASA's Deep Space Optical Communications Experiment, or DSOC. It will be the agency's first test of high bandwidth optical or laser communications between Earth and beyond the moon.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance. And Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
MVAC engine chill, burn 2.
Now to tell us more about DSOC, we have its operations lead, Meera Srinivasan, with Jasmine.
Thank you, Megan. So Meera, we just saw a beautiful launch, but now the work really starts for DSOC. So what does mission success look like to you?
Right. So, the purpose of doing optical communications is to be able to transmit much higher data rates than what we can do now with radio frequency systems. So, for us, the bottom line or ultimate measure of success would be for us to demonstrate those target data rates that we've established for ourselves over the course of the mission. But just to kind of beyond that, I think this is a technology demo. So what we really want to do is learn. And we have deployed all kinds of technologies, both on the flight side as well as on the ground side, in order to achieve these goals. So really, what we'd like to do is get enough data back so that we can understand, do our models work, how does our hardware perform, and what we can do to improve our operational concepts so that we can kind of mature this technology and bring it to the point where it can be fielded operationally. So that's mission success, is basically learning as much as we can.
Right, we're looking forward to that. And you're mentioning this data, so what information will DSOC be transmitting?
So what we're going to be focusing on primarily is this kind of test pattern data. This is what we've been using on the ground as we were developing the system, and so we'll focus on sending that initially. It's essentially like it's a test pattern, something that's pre-recorded, and it allows us to characterize the performance of the optical channel.
Right, and Meera, this is going to be a long-term mission for Psyche, but how soon do we expect to hear back from DSOC?
So provided that all the checkouts go as planned, approximately 40 days after launch, we hope to be getting some data down.
Okay, great. We're looking forward to that. Mira Srinivasan, thank you so much for being here today.
Well, thank you for having me.
Of course. Megan and Jim, back to you.
Now let's get to some social questions again. Jim, you've been doing a great job of answering them, so I hope you can continue your streak.
Let's do it.
All right, let's play the first video.
Hi, I'm Diego, and I'm from Serrano Elementary School in Moreno Valley, California. My question is, how long will it take Psyche to orbit the asteroid?
Good question.
Diego knows how to ask good questions. Absolutely.
Orbits.
Yep. So we start up very, very high as we approach the asteroid, go into very high orbit, and it's about 33 hours for the spacecraft to go around Psyche once, and we'll slowly lower that orbit, lower, down to about 4 hours. We're about 75 kilometers, maybe 50 miles or so above the asteroid at our lowest orbit.
Okay, and we do have time for one more question. We have this one from X, Space Case Sarah on X. What are you most excited about to learn about Psyche, considering how the Bennu sample was so incredibly cool?
Yes, boy, what a great success for that, really for the OSIRIS-REx team. That's spectacular. Of course, we're not taking samples from Psyche. We're doing what's called remote sensing, but we will be able to measure the chemistry, to look at the geology. We'll be mapping this asteroid just like the OSIRIS-REx team did with Bennu. So we'll learn as much as we can just short of bringing a sample back. Okay. So maybe in the future, decades hence, maybe we will go and bring some samples back from Psyche. But this mission will pave the way for that.
Okay, looking forward to maybe that.
Let's do it.
All right, thanks again. If you haven't sent in questions yet, there's still time. Again, use #AskNASA. Okay, we've been following along with the Falcon Heavy's second stage as it continues its journey out with Psyche. Let's bring back NASA's Daryl Nail and Nick Wolfman
burn 2
for the next operational milestones in this mission. Guys, go ahead.
Yeah, and there you just heard it, and you can see it. The engines start for the second time on the second stage of the Falcon Heavy rocket, now flying through space close to the country of Australia, and you can see it there. We've been tracking it all along, watching the fuel get prepped and prepared to restart that engine. Make this burn roughly about 2 minutes and 9 seconds.
Yeah, this burn's very important to get Psyche on its way, and Daryl, as you said, we've been tracking that, and as throughout that 45-minute coast phase, there have been call-outs for different ground stations that have been used around the United States, or around the world actually, to track this second stage, and you and I have been continuing to watch that telemetry, and this vehicle so far has performed very well today, and looking forward to this final burn to get ready for spacecraft deployment.
Those tracking stations that you mentioned, as we've heard them called out throughout the broadcast, also helpful with bringing us this picture right here, that high definition video pictures from space, which we greatly appreciate seeing and are able to show you exactly what's happening. As the spacecraft approaches the northwest coast of Australia, it will continue flying over the Indian Ocean. We will get ready to end that second burn and then prepare for the big moment, Mick, and that's separation of the Psyche spacecraft.
Yeah, and that's what Jim and I know all his team are excited about. We are too. Great successful launch today, watching that Falcon Heavy come back, those two side boosters land. But it's all about the Psyche spacecraft in this mission, and that's what we're very happy to be doing today, to deliver this on orbit and get Psyche on its way. And we are so happy to be a partner with JPL and the Psyche team to do that. So very looking forward to that video of separation.
So the burn about to come to an end here in just a few seconds.
MVAC shutdown.
There you hear the good call out of the MVAC shutdown. Still glowing red though in the cold darkness of space. We are in orbital night on the other side of the planet from where we launched this morning.
Nominal payload deploy, orbit insertion.
Confirming the orbital insertion there.
So yeah, it's confirming that we hit our mark exactly on that trajectory and where we needed to drop. Psyche, get ready to drop Psyche off, as Jarmaine had pointed out earlier in a segment on the trajectory. So that's really good to hear that stage 2 performed perfectly today, and we're getting ready for this last little coast prior to Psyche deployment. As you can see, the spacecraft right there on the front of stage 2.
Yeah, there it is, the Psyche spacecraft attached to the second stage, the camera looking forward where we can see that will be the image we will be looking at when separation happens, and we'll be tracking that as it goes along, of course. We lifted off today at 10:19:43 a.m. Eastern Time, 14:19:43 UTC time, and we've been flying for almost an hour now. And again, the teams at JPL certainly paying close attention, along with both here in California, or there in California and here in Florida. They're locked into this moment about separation.
Yeah, spacecraft team I know is excited about this moment, and the launch vehicle team is actually continuing to watch as they secure the launch pad here, and everything is going well. So teams are excited for this moment here. This is what it's all about, spacecraft separation.
And here is some of that team at the Mission Director Center in Florida, and now you're looking at the team in Pasadena, California at JPL, the Jet Propulsion Laboratory. This is the control room where they will run Psyche. We'll be monitoring the second stage and Psyche as they fly, and we'll be back in just a little bit. But for now, we'll send it back to Megan and Jim.
Really loving those live views that we're seeing of the spacecraft there. So why don't we actually, head back on over to JPL in California to hear what's happening now as they check out the spacecraft.
Thanks, Megan. We are about 1 hour after launch, and now everyone at JPL is eagerly awaiting the next major milestone. Here is a live look from our mission support area. There was a shift change just a short time ago. Right now, they're preparing for initial acquisition of signal from the spacecraft. I'm joined now by Psyche Flight Systems Manager Mark Brown, who is responsible for spacecraft development. Thank you for joining us, Mark.
Thank you, Raquel.
Now, you were part of that countdown shift.
Yes.
What was it like witnessing launch with your team?
Oh, it was very satisfying. The end of a long road for us developers, but then this is the start of the journey, that the spacecraft's going to take. We're very confident in how the spacecraft's going to behave. We've done all the testing and analysis that relates to this. There's always a little bit of nail biting that goes on with these things because you can't exactly test that exact ride to space, but we're quite confident. The other thing I would say is that we're relieved to have gotten to do launch today. There's a lot of moving parts with these launches. As you know, we got people in Florida, people here, people working off shift times, and just knowing that we're launched will allow everybody in their personal lives to kind of settle down. We now know what the schedule will be, going on from here. So.
And what can we expect to see next from Psyche now that it started its journey?
Right. What's really going to happen just in a matter of moments is we separate from the launch vehicle, and now the vehicle's really on its own. On the ride up, it was on battery power, so when we get those solar arrays deployed, we'll be looking to basically get to the arrays on sun, okay? And then we'll be looking for that first signal. And the first signal isn't necessarily a data stream like you would think about. Anybody of you that, in your house, if you're looking for your Wi-Fi, you can see that signal, but you don't necessarily start getting, Google and on the internet, right? So the carrier comes in first, and then we'll kind of sync up and we should get the data coming in.
And what kind of data will you expect to see from Psyche?
There's a range of, first of all, I'll say, is that, the spacecraft exists to carry the science instruments, but the science instruments are hibernating. They are off for launch. So we don't really see anything from the instruments themselves. We get some temperature data and, and some health data on those instruments. But what we're probably most interested to see is, are we power positive? Is the battery recharging, or are we still draining it? And then we're also going to be looking for, are all the temperatures kind of within safe limits, nothing too hot and nothing too cold? And those will be big indicators of, that we're good to go.
Well, thank you so much for that information, Mark, and joining us today.
Right. Thank you.
Back to you, Megan.
Well, as Mark said, we are soon expecting to see the Psyche spacecraft separate from the Falcon Heavy's second stage. We have an animation of that right now. Let's bring back Daryl and Mick. Everything still tracking, guys?
It certainly is, Megan. We are watching now, as you can see on your screen, the Psyche spacecraft looking forward from the second stage, as well as keeping a track on what's behind it as well, going between the two views. But
acquisition of signal, Hobart.
And there's just a call out that they've reached their next tracking station along the path that Psyche is taking. But the big show is right there. That shot right there, Mick, the Psyche spacecraft pointed into space. We are in orbital nighttime, currently flying. We've overflown Australia, approaching Papua New Guinea, where we are tracking a separation time in just about just a few seconds. Stand by.
Psyche payload separation confirmed.
There it is. The Psyche spacecraft going off into deep space.
That is
2.2 billion mile journey.
Yeah, I'm going to tell you that is an amazing shot right there. That is I'm so excited to see that. Probably not as excited as Jim, who's up at the hostess right now, but that is an awesome shot to see Psyche leaving the stage 2.
You see the team right there in the lower left-hand right corner. They are anxious as they see their baby go off into space towards an asteroid named Psyche, same as the mission. As you look at that Psyche spacecraft, you see the large diameter circle, which is where it attached to the payload adapter. That circle down at the bottom, that's a low-gain antenna. And that low-gain antenna will play a key role. It's got 3 of them. There's 2 more on either side. So if that one is the bottom, there's 2 on either side. It will play a key role on when we get that carrier signal that we just heard JPL talking about.
Yeah, I'm going to tell you, in all my years of doing launches, Daryl, that was a beautiful sight. I think that's the longest I've been able to see a spacecraft deploy. So that's an amazing job by the SpaceX team on that camera work on the second stage.
And so we'll keep tracking this as well, listening in for that signal. Momentarily, we're actually going to put up a waveform monitor where we're actually going to be looking at the signal, whether or not we can see, actually looking to see whether it comes in or not. That is a little more inexact because, as he described, JPL in the earlier interview, that spacecraft is going to start rotating as they try to lock that low gain antenna to a receiving station back here on Earth that JPL will see.
Yeah, I like the way he described it, like your Wi-Fi in your house, right? You find a signal, but you don't quite start receiving data and getting on the internet yet. That's kind of what they're looking for from the spacecraft here, that low gain carrier signal that they can know where Psyche is and that they've made contact with it, and then they'll continue to monitor that and so that they can then sync up and start getting the data and then starting their next 100 days of operation with the Psyche spacecraft.
All right, we just saw the Psyche spacecraft separate and go off on its journey into deep space towards the Psyche asteroid. We are now monitoring its progress to see when it makes that carrier signal back down to Earth, but we'll send it right now back to our other Earth partners, Jim and Megan.
Well, Mick had said it. Mick, there was a lot of excitement here when we saw Psyche separate. But now I feel like there's a little bit more of an anxious feeling because now we're waiting for the carrier signal, right?
Yeah, so we've just seen this beautiful wild animal released into its native habitat.
Okay.
Right? This is where that spacecraft belongs. This is what it was built for. Let's see if it phones home and we get it going.
Yeah, exactly. Yeah. And while we wait for that, why don't we take some more social questions? Again, we've asked people to send them in using hashtag AskNASA, and we've gotten a couple of them. So why don't we show the first one now?
Hi, my name is Santiago, a student from Repórter Elementary School. My question is, why do you guys think Psyche is a core of a planet?
Wow, these kids are asking awesome questions.
I know, I love seeing
Santiago,
kids
that's a
ask
great
these
question. So there's 3 pieces of evidence. One, we can see the colors, the way that the asteroid reflects sunlight. Looks a lot like those metal meteorites I showed you earlier. Also, astronomers can bounce radar waves off of Psyche from the Earth all the way out to the main asteroid belt, and they bounce back and very, very highly reflective, not quite like a mirror, but clearly suggesting metal. And the third piece of evidence is that when we can watch its orbit wiggle a little bit when Mars passes by, or when Jupiter passes by, or when Psyche passes by another asteroid, its orbit changes a little bit. So we can get its mass, we estimate its volume, also from telescope data, and that gives us an estimate of density. And its density, it's heavy. It's not that light granite rock, right? It's more like that heavy metal meteorite, that sphere that you held, right?
Yep.
Really dense. So we know that there's a metallic component in this one as well. It's one of the densest asteroids we've been able to measure.
So you guys do know a lot about it. Now it's about going out there and checking out to see if your hypotheses are correct.
True. It's still a point of light to us in the sky. We have to get close to it to turn it into a real world.
Okay, let's take another social question now. This one is from Christelle on Twitch. Is there a chance that the asteroid contains water?
That's a great question.
Yeah.
We don't really think so.
Okay.
But it might have some material on the surface that is more silicate rich, not so metallic. Maybe it was hit by other meteorites like the one that we just brought the samples back from OSIRIS-REx, which turns out to have a bunch of water in it. So there could be little places on the rocky parts of Psyche that have some water, but probably as a whole, we think it's mostly just metallic.
Got it. Jim, thank you so much for answering those questions, and thank you to everyone who sent questions in. Okay, so to recap, the Psyche spacecraft has been deployed and is now floating out in space on its own. The launch team is looking to confirm a signal from the spacecraft. So Daryl and Mick, how's that looking?
Yeah, Megan, we've been flying for 1 hour and 8 minutes now through space, and there you see, I believe we have a signal.
See the spike right there, the low carrier signal, and the JPL team clapping. Looks like that little spike in the center right there is the low carrier signal that they're looking for. So that is good news that we've received that carrier signal, and the team will begin their work.
And what you're looking at there in the lower left-hand corner of your screen is the receiving station for JPL, and they got that carrier signal, which came off of Psyche's low-gain antenna. It sent out that signal. There's not a lot to that signal. There's no data, no telemetry, just a basic signal that says, hey, I'm here, I'm out in space.
Yes, basically, as Jim said, phone's home, lets them know where they are, that they can start working to get their stuff set up and start acquiring data later on and beginning that next 100 days of operations that they need to do. So, very excited for the Psyche team, spacecraft team, successful launch of a Falcon Heavy today, and now they have contact with Psyche, and they can begin the work they've been working on for the last several years.
As for the spacecraft, what it's doing now is getting into a mode to deploy its solar arrays. They're going to get those arrays out, get it pointed in the direction of the sun, get that spacecraft power positive. And this is a process that, as they go through that, ultimately will lead to a lock on a telemetry signal, potentially several hours from now, where they can get a data stream and learn about the health of the spacecraft.
Yeah, absolutely. That's what they're looking for, and that's what's exciting for them to get these things started. So very excited to watch that and bring things to a conclusion here for this mission as we are, Daryl. But the Psyche team still has a lot of work ahead of them.
That's right. They got to go fly by Mars, which is their first destination in about 3 years.
Yeah.
And another 3 years after that, they'll be on their way to Psyche. So, of course, congratulations to the JPL team, LSP, NASA, SpaceX, everyone who's participated in making this mission a success. And I appreciate you riding shotgun here, partner.
I appreciate it, man. Another great, successful launch. And I would say to Jim, congratulations, my friend, and go Psyche.
All right, we'll send it back to Megan and Jim at the host desk.
Thank you, Daryl and Mick. Always good to do a broadcast with you
Those
guys.
guys are great. Those guys are awesome. Yeah.
Now, Jim, you are Psyche's imaging lead, obviously so invested in today's mission and all these milestones. I'm telling you, sitting next to you, it's like riding a roller coaster. So, deployment, you're like, and then it's back down to the carrier signal. And then we get the carrier signal, and you're like, and now we're waiting on solar array deployment. That's the next big thing, right?
Right. We knew even when we were writing the proposal many years ago, there would be 2 early critical events, right? We just saw one of them, the beautiful SpaceX launch and KSC team delivering us to the right path. We're going the right direction. The second one is that deployment of the solar panels. You saw that they're all kind of folded up against the side of the spacecraft, so they need to spring out and deploy so we can we can go power positive and get that sunlight turned into electricity to run our mission.
So a lot still to watch, but you're okay. You're
Yeah,
feeling okay so
for the
far.
moment, yes.
And I know, again, so many others are sharing in your relief and excitement. Let's get some more reaction from Mission Control at NASA's JPL in California. Raquel, I saw some cheering there once Psyche's carrier signal was confirmed.
Megan, that's right. Now let's take a look again into the mission support area. Like you said moments ago, we watched the team cheer and celebrate. Some of them were even standing up for it. But there is still more to come. And we are now joined by Lena Hutchinson, who is part of the Psyche launch team. Now, you're the launch activity lead, which means you're in charge of verifying the spacecraft and it's behaving as expected through launch. So, Lena, lots of work leading up to this moment. What does this mean for the team?
It's really exciting. It's really special to kind of know that the spacecraft is alive and healthy. So that first little blip that we saw was our first indication that separation was successful, and we are on our way to deploying our solar arrays. And hopefully we'll soon start to see actual telemetry where we can start verifying power and temperatures and a lot of other things like that. So it's really exciting, and for me personally, it's really special because this is the first mission that I have actually worked on that I got to launch since I started JPL. So it's extra exciting because now we're finally here, we're in space.
Well, congratulations on your first mission, and the work doesn't end here. So tell us what's next for Psyche and you during its long cruise.
Yeah, so as we keep going, we will start checking out all of our instruments, all of our hardware, making sure that everything survived the launch and is doing okay. So we'll be checking out all of the data and making sure that everything is doing well. And I will be continuing on with Psyche. I will be continuing as we checking out all these instruments and helping out and supporting the team with all that work.
Now, in your support role, we understand that the first 24 hours may look different from the first weeks or months. What's that like?
Yeah, so our main goal right now is to make sure that the solar arrays are deployed and that our telecom system is working, which means we can actually start sending and receiving data and commands. And that is like the most important thing to focus on right now, because those are the things that we absolutely need to be able to continue on. We have to have power and we have to be able to talk to the spacecraft. So that is the main focus for the next day or so. And then as we continue, we'll start checking out all the other hardware and making sure everything's looking okay.
Great, thank you so much, Lena. Now, Megan, that will do it for us here at JPL. The mission support area will continue to wait for acquisition of signal, which is expected to happen within the next couple of hours. So we'll send it back to you in Florida.
Great, Raquel, thank you so much. And back here on the Space Coast, you can see that Jim and I are not alone. We are now joined by Diana Calero from NASA's Launch Services Program. Today, she was filling in on console as the Assistant Launch Manager for Psyche. Important role, another successful mission for you guys. Congratulations.
Thank you very much. It was great. We had a great count. Actually, it was pretty clean. We got over a few issues early on in the count, but then everything was very quiet. Everything was very clean. Of course, we had some worries about the weather coming in with the 30% violation, But then we got, right before prop load, we got a great assist there by our launch weather officer for the 45th Space Quadrant, giving us a 15% chance of violation, which was awesome.
Yeah.
So going in, everything was nominal. There was a little bit of drama there, maybe in the last 5-6 minutes there when spacecraft was transitioning to internal power and they weren't quite getting their telemetry. They couldn't verify it, so everyone was holding their breath there for a little bit, but then they got it and everyone's like, everyone let out their breath at the same time.
Gosh.
But we had a beautiful launch, as you saw.
Yeah.
The recovery went well. Everything has been nominal second stage. Separation was nominal, payload fairing, everything looked great, and just waiting to hear that the spacecraft is getting their signal and was power positive. Again, this doesn't go easily. We have a great team assembled, the SpaceX team, the LSP, NASA team, the Psyche spacecraft team, including Arizona State University, JPL, everybody. It was incredible. The range, 45th Space Quadrant again, giving us lots of weather updates.
Sure.
You know, we had to stave off the first attempt, but everything worked out great.
Yeah.
Super team effort. Now, this was NASA's first primary science mission launched on a Falcon Heavy. So why did NASA choose this rocket?
So for this mission, based on the size and where it was going, right, interplanetary mission, we need the performance to be able to lift that up. Falcon Heavy had that performance, met the requirements. It was great. Falcon Heavy, when we selected this mission, was a fairly new vehicle coming out for SpaceX, so we had to certify this vehicle. Actually, NASA, we can't launch until we certify the launch vehicle. Psyche mission is what we consider a Class B mission, very important science mission. So we had to certify. It was a multi-year effort, again by a huge team. That we had to look at qualifications. Had a lot of boards looking at scrutinizing it technically to make sure it was a low-risk vehicle for this mission. So that culminated in the certification, Cat 3 certification of this vehicle before we can launch it.
Thank you for choosing the vehicle. It was a wonderful show with the launch and then the side boosters coming down.
Pass along our thanks for a great ride.
Yeah, thank you. It was an honor, and we're proud to be able to launch Psyche, and looking forward to getting some good science and being able to use that.
Yeah, how does it feel to be part of that, to be part of Psyche's journey out to discover things about our own planet, hopefully?
It is. I'm so proud to be able, just a small part of that, right? I mean, how many years to get Psyche to this level, right? And then even though we worked this mission for many years before, I feel it's just a small part of what that Psyche, that cog in the wheel to get that Psyche and that science back, right?
Yeah.
How long it's going to take to get there, and then come back with the science, and then use that science in a way that's going to benefit
Very
mankind.
important cog. Very important.
Teamwork, guys.
Teamwork's the only way.
Thank you, Diana. Now, before we sign off this morning, let's take one last look at today's spectacular launch.
15 seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange. M1D chamber pressure is nominal.
A view there from the onboard camera.
And that'll do it for us here at Kennedy Space Center for this live coverage of NASA's Psyche mission. A huge congratulations to everyone involved, and a big, big congratulations and thank you to everyone who participated, especially you, Jim.
Oh, that's very sweet. It's such an amazing thing to be part of this team. And I'm thinking of the team right now, right? I mean, hundreds, thousands of people around the country, around the world, that all have to come together and make this happen. So many skills, so many sets of experiences, so many stories, and so much adversity. This was done during COVID.
I was just going to say challenges.
COVID,
yes,
right?
yes.
And people overcame that, and now our spacecraft is on its way, on its journey.
And so what's next?
What's next is that we spend the next few months, we've got to deploy those panels and get power positive.
I thought you were going to
yes,
take a time to breathe,
sure,
Jim.
there'll be a little partying, I'm sure, responsible partying. But that we have to spend the next few months checking everything out,
Still
getting
a lot of
everything
work.
working,
Yep.
and all the systems, all the instruments, all the calibrations, all that kind of stuff. And we're just super excited to get going on this.
Yeah, literally. Cannot wait to see what you guys uncover, because, again, we are going to uncover something about our own planet.
It's
so
true. It's
thank
true.
you.
And we're taking data for generations to come. So
Yeah.
it's very exciting.
So thank you for posing the question.
Thank you for having me on the show.
Oh, gosh, of course.
We've got our purple and orange going on here.
Yes,
so
yes.
It's all good.
We're Psyche proud. And now you can continue to follow along this mission by scanning the QR code on the bottom of your screen. This is the one last QR code, guys. It'll take you to nasa.gov/Psyche. And together again, we are going to discover the mysteries of both Psyche and our home planet. And please join us again tomorrow at 11:30 a.m. Eastern for NASA's coverage of the annular eclipse, the Ring of Fire, a celestial event you won't want to miss right here on NASA TV. Everyone, have a great day.
270 meters and closing. Crew Dragon expected to converge with waypoint 1 directly in front of the International Space Station in less than 5 minutes. You can see the views right over the shoulders of Commander Shane Kimbrough and pilot Megan MacArthur. Kimbrough on the left, MacArthur on the right from that view.
From this view from the International Space Station, you can see what we were mentioning earlier, where Dragon was below the station. You could see that previously when it had Earth in the background. Now it is almost adjacent, or almost in the same orbit as the International Space Station, as it's making its way to the docking axis at waypoint 1. This maneuver from below the station to in front of the docking port is almost complete, just a few minutes away.
Getting great views from all around, from the station side, from the Dragon side. The outline of the station you see on the displays inside Crew Dragon is in line with the position of where Dragon is relative to the International Space Station. It's almost at the docking axis, about 2.5 minutes to go until it converges with waypoint 1.
And as a reminder, Dragon is flying autonomously, so they aren't using those display panels to fly Dragon, they're just using them to monitor each step of the way. Crew's basically just patiently waiting until they dock with the station.
Now seeing Dragon in a better view, a lot more clear now that it's only 240 meters away. You can see the nose cone clearly deployed, extended towards the space-facing side or zenith side.
A really good zoomed-in view, and you could almost make out those 4 bulkhead thrusters on the forward portion of the Dragon capsule.
There you go. The Cronus is adjusting the aperture of the station cameras.
Dragon SpaceX on the big loop. Approach 1 and soft capture ring extension will begin shortly. Dragon will continue to waypoint 2, with the additional lighting assessment occurring at 110 meters, as previously noted. For awareness, if sunlight results in the loss of the Dragonite geofilters, Dragon will autonomously retreat back to waypoint 1, remaining on closed-loop control using the time-of-flight filters. I'll copy.
We are in a handover period, so we may have missed a call as we were switching from Teeter's satellites. We're looking at about 20 seconds to go until we converge with waypoint 1. There's going to be an approach burn maneuver using the Draco thrusters. It's called approach 1, and that'll move Dragon from right in front of the docking axis, 220 meters away, and start moving in, closing in to waypoint 2, just 20 meters away from the docking axis. Of course, they'll be monitoring along the way.
We did hear the Corps mention that they are going to have a checkpoint to make sure that there isn't too much sunlight on the space station, which will prevent Dragon from docking. If that does happen, Dragon will autonomously back out and wait until the sunlight has cleared to ensure a good docking with the space station. Because this is all autonomous, it uses some visual cameras to align with the docking port. So it's really important that we don't have that sunlight getting in the way.
Sections over on the big loop, sound check. SpaceX has you loud and clear on the big loop. Helm me.
Loud and clear. Your last call, we copied most of it, but you cut out towards the end there. I'm not sure if there's anything important for us.
Copy. I'm going to repeat the end of the call. We did have a TDRS handover. Just for awareness, following the lighting assessment, if we continue but sunlight results in a loss of the Dragon Eye geofilters, Dragon Eye will autonomously retreat back to waypoint 1, still on closed loop control using the time of flight filters. How copy?
Okay, we copied all. Thank you very much for repeating.
No problem, Shane. And for awareness, the C2V2 link reconfiguration has been completed.
Copy C2V2 complete.
There, the Corps just reiterated that they will be checking to make sure that the sunlight is not in the way of the visual systems between Dragon and the space station. If that does happen, Dragon will autonomously retract and wait until we do get some good visual views for these systems to dock with each other. So
that's right. Crew Dragon resilience actually coming into view a little bit clearer now from the cameras aboard Dragon. Dock to the Zenith port.
That was on the upper portion of the screen.
That's right. Now again, to reiterate, Dragon has passed waypoint 1, 220 meters in front of the station, executed a burn maneuver to go ahead and move in, so we're in approach 1, and it's heading towards waypoint 2. Now inside the keep-out sphere. It's currently in the process of extending its soft capture ring that'll be used to dock to the international docking adapter of the forward port. We're monitoring the visual systems of Dragon. It would execute an automatic retreat if the sun was interfering with the optical systems as it makes its way towards an approach. We're at about 150 meters away from the station.
We have such a great camera view here. You can really see the detail on Dragon. Again, those 4 bulkhead thrusters. You could almost read the logo, the Dragon logo on the side of the vehicle.
That's right. We'll get even better views as it makes its way even closer to make contact and capture with the space station.
There it is.
Yeah, based on the trajectory here, we may even anticipate a capture a little bit earlier than anticipating. We were looking at about 2:10 a.m. Pacific time. It might be at maybe closer to 2:07 p.m. The features of the space station coming into view very clearly.
Yeah, you can see a lot of the detail there, and as you mentioned, the Crew 1 Dragon.
This is the 6th station on the big loop. Procedure review complete, ready for docking.
Houston copies.
All right, that was confirmation from Victor Glover aboard the International Space Station. From the space station side, he is go for docking. The soft capture ring itself is fully extended. We're 115 meters in closing.
Looking at your screen, the port that we are going to be docking with is directly in the middle of the screen, that circular area on the International Space Station.
Station Houston on 2 for Ike regarding SSC 17 and D2DM. We are seeing some strange configurations on the video, and we would like to close and restart that. We can take care of that from the ground if you would like. Absolutely. If you're seeing nominal, that works for us.
Okay, so Victor Glover aboard the station still has...
And Dragon SpaceX soft capture ring extension is complete. Additionally, we did beat the sunlight for the Dragon Eye filters, so we are not going to command a hold.
All right, so that's great news. We passed the 110-meter checkpoint that the ground operators were referencing, making sure the sun wasn't interfering with the optical sensors, the Dragon Eye, that are part of the guidance and navigation and control system aboard Dragon. We passed that check mark. We're good to go. We beat the sun there. So we're now inside 80 meters and closing. Dragon will pause at 20 meters. That's designated as waypoint 2 to conduct a go, no-go poll for the readiness on both the Dragon side and the International Space Station side, making sure everyone is good for docking. If we are go, we expect to dock during this pass over an orbital daytime. Expected in less than 20 minutes. Some of the features there, you can see a lot of the visiting vehicles on board station. At the bottom is a Russian Soyuz vehicle that delivered crew to the International Space Station. Just in front of that, or actually above that, is the Crew Dragon Resilience docked to the Zenith port. Once Crew Dragon Endeavour arrives, there will be 2 Crew Dragons attached to the space station.
And this view from Crew Dragon looking at the International Space Station, it looks like it's this very slow and steady movement, but in reality they're moving at 17,500 miles per hour.
The rendezvous operations are absolutely incredible. You can sort of see the Northrop Grumman Cygnus cargo craft as well, some of the ultraflex solar arrays coming into view a little bit clearly.
And you could see that Crew 1 Dragon vehicle on the top of your screen. Once Crew 2 docks to the International Space Station, we will have...
Muito bem, galera, muito boa tarde para todos. Então, estamos de volta aqui, já encerrando a nossa transmissão de hoje. Tivemos aqui o lançamento da missão Psyche. Aí vemos as imagens da NASA, da Estação Espacial Internacional. Isso aí é uma gravação. Deixa eu baixar aqui meu retorno. Espera aí, estou agora. Então, isso aí é uma reprise, né, melhor dizendo, do acoplamento dessa Dragon. Mas, bom, galera, eu quero mais uma vez agradecer a todos que estiveram conosco, a todos que vão assistir depois mais tarde. Muito obrigado a todos pela audiência. Por favor, deixe o seu like, isso ajuda no compartilhamento, no engajamento do nosso canal. Estivemos, como vocês bem sabem, um pouco fora aqui das nossas atividades por conta de problemas com a nossa máquina, mas já estamos de volta. E eu quero agradecer a vocês de coração, muito mesmo, pela presença de todos, tá legal, gente? Eu quero também agradecer a... Peraí, cadê? Deixa eu abrir aqui a minha câmera. Muito bem. Eu quero agradecer a Internet, o Apoio Cultural da Internet, a maior e a melhor rede de fibra ótica da região, atendendo ao sul do Espírito Santo, norte e noroeste fluminense, região dos lagos e agora também chegando ao Grande Rio. Acesse o site www.itanet.com.br e confira os combos e as facilidades que a Internet tem a lhe oferecer. Mais uma vez, muito obrigado. Fiquem todos com Deus na fé de cada um e até a próxima, se assim Ele nos permitir. Tchau, tchau.